So, the first question I asked you, I said, what is dilution factor, right? Right?
Yes.
Okay. And now we're looking at what dilution is properly. If you're asked in an exam, in a chemistry exam, say dilution is the process of reducing the concentration of a solute in a solution. So there's a solute in a solution. A solute has been mixed with solvent to form a solution. So the concentration of that solute in the solution is what we're trying to reduce by diluting it. So by simply adding more solvent to the solution, and the solvent could be water or other solvents. Is that clear? Is that clear? Can you hear me? Can you hear me? Let me know if you can hear me. Hello? Can you hear me? Because I was asking, but I was not even seeing any response. That's why. Now, we can say it's the action of making a liquid more dilute, but when it comes to chemistry, you must mention, concentration being reduced, concentration of solute being reduced by adding more solvent, not just by adding anything. So the solvent could be water and the solvent could be any other thing. Now, back to dilution factor. Dilution factor is the factor by which the stock solution is diluted. It may be expressed as the ratio of the volume of the final dilution V2 to the volume of the initial or to the initial volume removed from the stock solution. So, in a nutshell, dilution factor is the total number of unit volumes in which your material will be dissolved, or the number of times uh, the number of time the solution is diluted. So that is a factor that has to do with how many times dilution takes place. Is that clear? Can you hear me?
I hear
Hello, are
you,
you?
sir.
Okay, okay. So you can put this down quickly and we move on. Put it down quickly. Question is asking us to check which of the options 1 to 4 are correct regarding the ionic character for calcium chloride. He said calcium has high ionization energy. The question is, what is high ionization energy? I mean, what is ionization energy, let alone high or low? So this one says calcium has low ionization energy. The third one says chlorine has high electron affinity. And the last one says chlorine has high ionization energy. Now, there are two opposite character here. This one is saying calcium has high ionization energy, which is not true. The question is, what is ionization energy? Now, the ionization energy is the quantity of energy required, the quantity of energy that an isolated gaseous atom in a ground electronic state must absorb in order to discharge electron. So that is the quantity of energy required to remove an electron from the outermost shell of an atom. So we can say this, that is, it will absorb a kind of energy in order to discharge electron. So the more the electron in the outermost shell, the higher the ionization energy. So when we compare calcium and chlorine, chlorine has more electrons in the outermost shell, which is 7. Calcium has 2 electrons in the outermost shell. So 7 is greater than 2. So definitely the one with 7 will have higher ionization energy. So that's why this first option is not correct, okay, for calcium, but it is correct for chlorine.
Excellent.
Is that clear?
Yes, sir.
It is correct for chlorine, but it is not correct for calcium. So if we are picking the correct ones, we'll firstly pick this as correct because it has. Now let us look at the other terms and see why they are correct, okay? Calcium is a calcium has low ionization energy. Yeah, that is correct based on our explanation. Is that clear?
Yes,
Because it
sir.
has smaller electrons, valency electrons in terms of comparison with chlorine. But this one says chlorine has high electron affinity. Now that will lead us to the next point. What is electron affinity? What is electron affinity? Now,
Excellent.
electron affinity is defined as the amount of energy released when an electron is added to a neutral atom to form an anion. Okay, here is still talking about energy released, while ionization energy is talking about energy absorbed. Take note of that. But it is due to the same process. So that means when you are removing an electron from an atom, there will be energy absorbed, there will be energy released. So the energy absorbed, in order to discharge, that is energy required to get to remove that one electron is ionization energy. But the energy released when an electron is added to that neutral atom to form an anion, that like chlorine, so that energy is known as electron affinity. Or in order not to get confused about energy absorbed, energy um, released, you can define electron affinity as the a measure of attraction between the incoming electron and the nucleus of the atom where it is going. So the it's a measure, say electron affinity is a measure of attraction between the incoming electron and the nucleus. So the stronger the, you know, we're talking about the attraction now. Like in chlorine, the electron affinity is going to be high because chlorine is positioned to be requiring more to always want to hijack electron because it wants to balance or form the octet state. Is that clear?
Yes, sir.
So that is what we are referring to. So I will leave this point for some time, for a few seconds. Whatever you want to jot it down. I'm going to ask you questions. So we continue then. After dealing with this, he's talking about biodegradable pollutant. Let's see. It says, which of these is an example of biodegradable pollutant? So anybody want to answer it should signify. So is there anybody that want to answer this? Yeah. Biodegradable pollutants are natural organic substances which can be decomposed or which can be sewage, okay, which can be consumed by natural microbial or biological processes, and they can be converted into CO2, into water or simple organic molecules. So sewage is an example of biodegradable, that is, they can decay, decompose. So now let us look into what are more examples, of biodegradable materials. Maybe you should all mention uh, one by one, more examples of biodegradable materials or pollutants. Yes, what are more examples? We can talk about food wastage, leftover food. Then we can talk about paper waste. Then we talked about sewage, which is the same as human waste. Also, manure. So if we talked about examples of biodegradable materials, we can also look at some materials that we see that are not biodegradable. So we can say um, samples of examples of non-biodegradable materials or pollutants. Hold on, let me try that again. Examples of non-biodegradable pollutants. So we have lots of them. We can talk about glass, plastic, right? Plastics, metals, okay? Are you hearing me?
Ceramics. Ceramics.
Okay, okay. Ceramics, computer parts, that's part of electronic devices. Then batteries. We can talk about medical waste, plastic bags, carbon paper, and so on. Okay. Let's see. Remember, we mentioned that paper is a biodegradable pollutant, right?
Yeah. Yes, sir.
But carbon paper is not. Okay.
That's okay.
So take note. That's a very tricky one. They will put a lot of things and they will put carbon paper. They will now say you should pick the one that is biodegradable. If you pick carbon paper, you're gonna miss that. So jot down whatever you can jot down. Then I'm going to. Here is the next question. It says state Faraday's first law of electrolysis.
Electrolysis.
So who want to try that?
How do you explain that? Development. You say on them.
So Messi, read this. Messi, read it. Let me hear you. Oh, you are reading.
Vice President Electrolysis states that the amount of the salt tempered parts developed from electric directly proportional to the quantity of energy that passed through the electrolyte.
So what does that mean? Who can tell us what that means? Reading
Yeah,
something.
it means that
Okay.
if there is a free, let me say, free animals, and they have let's say equal volume. So the first animal, we have lower let's say quantity of electricity, like the two more in
Wait. Let's check this alternative way of defining it. You can say, or
What is this thing now?
the mass of an element deposited at the electrode during electrolysis is directly proportional to the quantity of electricity passed across the electrolyte. Now, listen, Sarah, what does this one mean? Because we're still talking about the same thing. So, what's the meaning of this?
The mass of an element deposited at the electrode is directly proportional to the quantity of its it's the same thing now.
So, what does it mean? Because
That
Moses didn't get the explanation to this. That's why I brought in the second one. So, what does this mean?
so the mass of an element deposited at the electrode is what it means is that the amount of a substance dissolved from an electrode is deposited is like I don't
Wait
even
a
know how to
minute.
put it
Hold
in.
on, hold on. The meaning is that the greater the quantity of electricity passed through the electrolyte, the greater the mass of the element deposited. What did I say it means?
It means the greater.
the greater the amount of electricity,
Push. I don't know how to come and ask me. No, everybody will go. Mm-hmm. Even down here, I do anything else to school right.
So that is the meaning of the
I said, even down here,
directly
the
proportional that you
living
see there. The greater the quantity of
room,
electricity
to
passed through the electrolyte, then the greater or the more the mass of element deposited at the electrode. Okay, is that clear?
Yes, sir.
Okay, so we're going to look at another question. You can jot down whatever from this page. I will still ask you questions before we finish. So jot down. When I say jot down, I mean jot down.
It means jot down.
Okay, so let's see. Can you hear me now? Can you hear me now?
Yes, sir.
Okay, okay. So the next question says to distinguish between a strong and a weak electrolyte. Distinguish between a strong and a weak. But the first thing we need to talk about is um, what is an electrolyte?
It's a negative ion. It's a compound that it's electrons.
You said
Study the
electrons, right?
solution and then. Yes, sir.
Hold on.
Amen. Amen.
I want to. Okay, we can say an electrolyte is a compound that dissociates into ions when dissolved in water. So that's the first thing we're looking at. What is an electrolyte? What is an electrolyte? So an electrolyte is a compound that dissociates into its component ions when dissolved in water. Or you say it's a substance that dissociates in water, into charged particles called ions. You're still saying the same thing. So that is now to, or you can just add and say, okay, it's a compound which conducts electricity when dissolved in water or in a molten state. So whether it's in a liquid or in a molten state, it conducts electricity. It allows the passage of electric current. So that is now to differentiate between or to distinguish or differentiate between weak and strong electrolytes. Remember, we said electrolyte, when it's dissolved in water and there's passage of electricity, it dissociates into its component layer. So strong electrolyte dissociates completely in aqueous solution, while weak electrolyte dissociate slightly or partially. So they don't dissociate completely. So that is the answer to this. So strong electrolytes dissociate or ionize completely in aqueous solutions, while weak electrolytes dissociate or ionize slightly or partially in aqueous solutions. Is that clear? You are muted. Is that clear? Can you hear me? Can you hear me? Are you hearing me? Okay, okay. So we can have a
Hmm.
list of weak electrolytes and strong electrolytes. So let me check this thing. You can't see this, but let me try and make it a little bit bigger. So this list consists of weak electrolytes, okay? Acetic acid, hydrocyanic acid, ammonium hydroxide, ammonia, hydrofluoric acid, carbonic acid, mercuric chloride, chromic acid, boric acid, nitrous acid, ethylamine, dimethylamine, trimethylamine, alanine, oxalic acid, tap water,
Hmm.
your normal H2O, phosphoric acid, zinc sulfate. I'm going to ask you to mention some of these. So if you are jotting down, jot fast. I just mentioned, about 15 or more now. So you should be able to at least pick one or two things, even if you claim you can't see the book. Okay, so I think we can move on now. Let me see. Electrolytes. If you check on this page, you'll be able to see
Hmm.
hydrochloric acid, hydrogen bromide, hydrogen iodide. You know, all of them mostly containing hydrogen. Then the strong bases are also strong electrolyte, like sodium hydroxide, uh, potassium hydroxide, the hydroxyl group, and salts also, chloride salt. Like this is sodium chloride, magnesium chloride, and so on. Then we've already mentioned the weak. So weak acid and weak bases are weak electrolytes. Then strong acids and strong bases are strong electrolytes. So let's take note of this. Then I want to ask you a few questions right away before we end the class for today. Okay. Exactly. Review right away.
Where do
Review.
I washing my clothes?
Um,
Moses,
please,
so yeah,
please,
where are you going to?
please listen. Um,
Do something.
Moses,
Yeah.
here comes your question.
Here comes your question.
What is electron affinity? You have just a few seconds, 30 seconds.
5, 4, 3, 2, 1, 0.
What did you just say? Okay. Anyway, so when you get the note, you go through that. Take note, okay? The next question goes to Messi. Messi, state you're
Your
on your
question.
own. Moses, you're on your own. Messi,
I like. Give
state
my pen.
Faraday's first law of electrolysis. You
Give
have
my
30
pen,
se-
Moses.
you have 30 seconds.
No, give my pen.
Messi, Faraday's first law of electrolysis.
No, me hear the article.
Mm, okay. So the
The
greater
only
the
thing not
quantity
needed.
of now um
Sarah,
Taye,
Metai.
what is an electrolyte? Hmm? Anyway, take note when you take note when you get the note. Thank you. Then Sarah,
Yes, sir.
distinguish between a strong and a weak electrolyte.
Okay, sir. So, strong. Are you drunk? Sorry. So, strong electrolytes ionize quickly in aqueous solution. What? Shut up. While weak electrolytes ionize slightly in aqueous solution.
Is that short of part of the something?
Sir,
You said shut up when you were defining something. Is that
Moses
shut
was
up?
talking to me like, "Tell him to shut up because
Okay.
he's not needed. Hey, leave my hair alone.
Okay, okay, okay.
Hey,
All
you
right.
just cut your hair. See her hair remove.
So that is where we'll be rounding up the class for today, okay?
What's give me the book?
Okay. Are you hearing
It's not
me?
there to get me.
Okay. Meanwhile, let me just show you